Hey guys, Mr. B here, and this video is going over the BAGO Isotopes lab. So if you're in class, you might be doing this activity in person. However, if you're at home, this video is mainly going to be for you. So you can use this video to either follow along if you're doing it in class, or this video is just going to be a virtual lab for you. So let's get started. All right, so welcome to the first portion of the lab here. We have got a bag of brand new element just discovered called Legumium. So what we're going to do is we're going to dump out all of these samples of Legumium, and we are going to take a look and see what we've got. We're going to count them, and we're going to put in our data table how many we have of each one. So it looks like we have three different types of isotopes here. We have a larger Legumium, which I believe is Legumium 6. We have then a little bit of a medium-sized Legumium, which I think is Legumium 5. And then we also have a small isotope called Legumium 4. So we're going to count again how many we have in our sample of each of these. So here we go. Let's try to sort them out. So the big ones are not too difficult to sort. All right. Let's grab the medium ones here, these Legumium 5s. And then we have all of these Legumium 6s. All right, so let's do a quick count here and see. So for Legumium 6, we have 1, 2, 3, 4, 5, 6 Legumium 6 isotopes. For Legumium 5, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 Legumium 5 isotopes. And for Legumium 4, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16 Legumium 4 isotopes. So we're going to write that down on our data table. All right, so usually I'd be doing this on the computer. However, I am doing this in paper today. So this is what our data table should look like at the moment. These are our three isotopes, Legumium 6, 5, and 4. I just will put LG for a symbol. You can make whatever symbol up you want. Quantity we had in our sample, we had 6 Legumium 6s, 11 Legumium 5s, and 16 Legumium 4s. As for their mass, that's what the 6, 5, and 4 stand for. So Legumium 6 is 6 AMUs for its mass, Legumium 5 is 5 AMUs for its mass, and Legumium 4 is 4 AMUs for its mass. All right, so now we're going to count the total number of Legumium isotopes in our sample. Then we need to do some math to find the total mass of each one. We're just going to do some multiplication here, and then we'll move on to calculating out the average atomic mass. All right, so we're going to count all of these up, and we are going to, again, write that down as the total number of Legumium isotopes in the sample. I, again, had 6, 11, and 16. So if I add those together, I get a total of 33 Legumium isotopes in my sample. Your sample in person might be a little bit different, but it should be pretty close to that. All right, so now we're going to find the total mass that we have of each one. So we're going to take as 6 times 6 AMUs to get the total AMU mass for Legumium 6 isotopes. Same thing for Legumium 5s and Legumium 4s. All right, so now here are my total masses. Again, I just did some basic multiplication. We're going to add that up then to find our total mass of Legumium in the whole sample, and then we'll move on to finding our average atomic mass. All right, so I added all of my masses up, and I got a total of 155 AMUs. Hopefully yours is close to that. Again, yours might be a little bit different depending on how many Legumium isotopes you had in your sample. Each bag is a little bit different, but they also can be similar. And now let's move on to calculating our average atomic mass. So how to do that on the, oh, that's not the right side. Here we go. This is the right paper we're looking for. On our front side of our handout, or document, or the first page, we should say, we have an equation here that we can use to find our average atomic mass. So we're going to take the number of isotopes we have for one of them, which let's just say is Legumium 6, multiply that by the mass of the isotope, which is going to be 6 AMUs, plus 5, or the number of isotopes for Legumium 5 times its mass, plus Legumium 4 number times its mass, and then divide that by the total number of isotopes we had in our whole sample to then get our average atomic mass. So I'm going to do that for my numbers. I want you to do that for your numbers, and then we will come back and see what we get. All right, so I've done my math out, and I got an average of 5.03 AMUs. Now, the number that you have here should be between 4 and 6. If it's smaller than 4 or larger than 6, you messed up somewhere, okay? Also, this number should be closest to the number of isotopes that you had the most of. Now, I had 11 Legumium 5s and 16 Legumium 4s and only 6 Legumium 6s. So it is certainly at 5, and we did have the most Legumium 4s. However, Legumium 5 and Legumium 6, if we were to add these together, right, we have 17 of the heavier ones and 16 of the lighter ones. So it's roughly a 50-50 split between the light one, Legumium 4, and the heavier ones. However, we do have 17 Legumium 6 and 5s. If we add these together, that's 17, which will push this average a little bit closer to 6 than it will to 4. So it makes sense that this is 5.03 rather than like 4.97. Okay? Again, your number here should be reflective of what you have up here in terms of your quantity. All right, so let's move on then to looking at the post-lab questions. All right, so we're done with the counting of all our Legumium isotopes, and now we're going to answer some post-lab questions. So, first question number 1 says, calculate the number of neutrons in each Legumium isotope. So I'd like you to try doing that yourself right now. Pause the video, and then you can hit resume, and I'll tell you what I got. All right, so in order for us to find the number of neutrons, we need to know how many protons does Legumium have. Now, on the very front side of this handout, or the first page of this handout, there was an atomic number for Legumium given, and that is 4, which means that Legumium has 4 protons in its nucleus, no matter what kind of isotope it is. So for us to find our neutrons for Legumium 6, we'll take 6 minus 4. 6 is the mass number, 4 is the atomic number. Subtract those two, and for Legumium 6, you will get a total of 2 neutrons. Okay? For Legumium 5, again, mass number is 5, atomic number is 4. 5 minus 4 gives you 1 neutron. And lastly, for Legumium 4, 4 minus 4, you get 0 neutrons. All right, question number 2 says, according to the sample, which Legumium isotope is most abundant in nature? So again, I'd like you to pause the video, try answering this question, and I'll let you know what I got. All right, so this is going to change based on your sample that you're dealing with. So if you're doing this in person, it might be a little bit different from what I'm going to give you. However, based on the samples that I had in this video, the isotope that is most abundant is going to be the one that you had the most of. So in this case, for us, and for this video, I had 16 Legumium 4s and only 11 and 6 Legumium 5s and 6s, which means the Legumium isotope that was most abundant in nature for me was Legumium 4. All right, question number 3, it says, for each Legumium isotope, give the proper isotope notation. All right, so again, pause the video and try writing that out, and then you can hit resume, and I will show you what it is. So to write isotope notation, you need 3 things. You need an element symbol, a mass number, an atomic number. Now, as for the element symbol, this element doesn't exist, so which means you can kind of use whatever symbol you want. It should be a capital letter, and then if you want, you can also have a lowercase letter. Okay, so for this one, I chose LG, but you could have gone with like L or LM or LE or pretty much whatever you wanted. And then from there, with the symbol, you got to put your mass number and atomic number on there. So here's what I got for my 3 isotope notation symbols. All right, last question. It says, number 4, if additional Legumium 5 isotopes were added to the sample, how would the average atomic mass of Legumium be affected? So pause the video and answer this question, and then I will tell you what I got. All right, so if you added more Legumium 5 isotopes to the sample, what is that going to do to the atomic mass of Legumium? Remember that atomic mass is a weighted average, so the more you have of a particular isotope, the closer the average is going to be to that number. Okay? So if we added more Legumium 5 isotopes to our sample, our average atomic mass will be closer to 5. Now ours, at least mine, was 5.03. Basically all that would do is make it 5.00. Okay? But if your number was a little bit higher than 5 or less than 5, it would just make it closer to 5. All right, guys, that is it for this lab. Thanks for sticking with me. Hopefully you learned a little bit about atomic mass and isotopes. But again, as always, if you have any questions or need any more help, always feel free to email me, reach out to me, talk to me in class. Just make sure that you get your questions answered. All right, I'm Mr. B. Thanks for watching. See you in the next one.